program, alright? Divide to 32-bit integers. Fine. How am I supposed to divide to integers? We have studied division almost in when we were in primary, right? So suppose that is, this is 71. Alright, yeah, I hope you guys know it. So 71 divided by 7. How do you guys divide it? 7, 1s are 7, and then again 1. So 0, 0, the remainder is going to be 1. So this is my quotient, this is my remainder, right? Yes, okay. So what is this? This is dividend, okay, and this is my divisor. Fine. So what have I done here? 71 is equal to 7 into 10 plus 1. Okay. So dividend is equal to divisor. Dividend is equal to divisor into quotient plus remainder. So my question is asking for this quotient. Alright. Remainder we can automatically get the remainder if at all we get the quotient. Okay. Because we know the dividend, we know the divisor. If at all we find the quotient, how do you get the remainder? You can just do 71 minus 70, right? Which is 1. You get the remainder. So, remainder is quite simple. We don't have to find the remainder. All we need to know is what our quotient is going to be. So, how can I write this 10? This, we are supposed to do it, right? 32-bit integers, bit. Do it in form of bits. So, when you talk about bits, you are going to talk about 2's, 0's and 1's. Alright? So, how can I write this 10 in the form of 2's? Can I write it as 7 into 2 power 3, 7 into, better understanding, 8 plus 2, right, which is nothing but 7 into 2 power 3 plus 2 power 1. So, can I write it as 7 into 2 power 3 plus 7 into 2 power 1, alright. So, this is nothing but what? Plus 1 is going to give me what? My dividend, alright. So right now we have to calculate what? The quotient. Okay, so IA used to find the quotient. So what is the quotient right here? Quotient is going to be 2 power 3. Quotient is what? 10. 2 power 3 plus 2 power 1. Alright. So you see everything in the form of 2's, right? What is crossing your mind? It must be something of the form that to multiplication. Multiply into power of 2 comma x. It is in this format. So we have studied the operators. What crosses your mind looking at this? Into. Little meat is red. Into. Multiply. So it is going to be what? My left shift operator. Alright? Left shift operator. So we have to use the left shift operator. So to find the quotient, I only have to get what? 2 power into power of something. So how am I supposed to extract it? Okay? 1. What is it? It is 1 into power of 2 comma 3, which is nothing but 1 into 8, right? You told it right. So 1 left shift anything is going to give me what? This one only, right? So 1 left shift, my power of 2 comma I is going to give me what? My quotient. Okay, note this out. 1 left shift power of 2 comma I is going to help me extract the quotient. But in order to extract the quotient, right, what should we do? We should try out all possible combination of the divisor into 2 power this. So how am I supposed to do that? Alright, they have given us that fine. They have given you another easy thing also. They have told you yes, it is 32-bit only. So at max, it is going to be only 32. Alright, so Q is equal, how am I supposed to find the quotient out? Quotient is equal to 1 left shift power of 2 comma I. Alright, yes. So right now what we will do is that 32-bit, they told us that yes, it is going to be 32-bit. And then if you notice now, we started off with 7 into 2 power 3 and then we went for 7 into 2 power 1. You start from the greater side. You don't do 7 into 2 power 1. Okay, fine. Or 7 into 2 power 2 will also go right. You don't think that way. You start from the greater bit and then you go to the less bit. Alright? So, initially what am I supposed to do is that let me run a for loop. Since it's 32-bit and I is equal to, I'll start from the 31st bit and at max it can go to 0, I minus, right? Fine. I'm trying to find out what? The quotient. So int QB0 and some temporary variable is equal to 0. Fine. So what is this temporary variable actually going to do, alright? So right now, what did we told? 71 is equal to 7 into 2 power 3 plus 7 into 2 power 1. So what was this? This was a divisor. Alright? Yes. So divisor into 2 power this I. This is the I value that I am traversing. This is I. Alright, so let me go for everything. Alright, so temp plus, okay, divisor into 2 power. So it is going to be divisor left shift, okay, left shift what? This I. Right? Can I write it in this way? Left shift not power to come. This is going to be I only. Okay. So similarly here it is this statement can be written as divisor left shift type, right? That is nothing but divisor into 2 power I. Alright, power of 2 comma I. Fine, makes sense. So it is divisor left shift type. So temp plus divisor left shift I. If the value that I get here, it is lesser than or equal to the dividend. What is a dividend? 71. Alright, I can't do 7 into 2 power 23. Okay. And then tell yes it's divisible. How can I even tell it? Only if it's less than the dividend you can even divide it, right? I can't divide 71 by 72 and tell yeah it's divisible. No, I can't do that, right? So anything that is less than or equal to dividend can only be subtracted from it. Right? So if temporary variable plus divisor into 2 power I is less than or equal to dividend, then what am I going to do? Change the value of temp. What is this value of temp, right? So initially you start from 7 into 2 power of 31. Alright? It is obviously not less than dividend, so it will not go. Again, it is 0 temp value plus 7 into 2 power 30. Again, this condition will not come. So you go on 0 plus 7 into 2 power 29 and then you go again and again until you reach 0 plus 7 into 2 power 3. Alright. So 7 into 2 power 3 is going to be 7 8 is 56. Fine. 50. Let's have another previous number. 7 into 2 power 4. 4 to 2 power 4 is going to be 8. Sorry. 16. Right? So 7 into 16 is obviously greater than 71. Alright, what is it? 112. 112 is obviously greater than 71. So this condition can't be right, but rather 7 into 2 power 3 is only 56. And yes, it is less than the dividend. So what I do? I take it into account. Alright, so how is the temp value going to change? So the next time I do I'll have to only calculate for 71 minus 56. Correct? I need not go for again 71 again. Right? So the temp shall hold the value of 7 into 2 power 3 already. And then I'll go with 7 into 2 power 2 again. So that is going to give me a value of 28. So just hold this one. So temp, I'm telling you that I'm going to hold the temporary variable as this. Temp plus divisor left shift of I. I'm holding the value of temp already. And then I'm going to get the value of quotient. So what is quotient? Quotient will be 1 of 5. 1, 5. Alright. So right now I already have 7 into 2 power 3. So what is happening? I'll already have 56 in hand. So how much more should I get? That must only be added, right? So 7 into 2 power 3 is 56. So I already have 56 in hand. Fine. Plus divisor into 2 power 2. So which is nothing but what? 7 into 2 power 2 will be some force of 28. Oh, okay. So 56 plus 28. 5, 6, 8. 84. 84 is it less than or equal to 71? No. So obviously this shall not come. So again, what will happen? 7 into 2 power 1. Alright, so which is nothing but what? 14. So 56 plus 14, which is 70, it is less than or equal to 71. So because this is 10, you already got this much. So how much more should I need in order to get the dividend is our question. Alright. So this is how you are supposed to do. So you are going to store the value of temp again and again. So you want, I hope I tried to deliver it and I hope you guys got it right, okay? So all that matters is this statement and here this statement. This OR operator is basically used to add words. So initially I already have 2 power 3 here, okay? So using this OR operator, I'm going to add the extracted bits. Okay, it is going to be plus 2 power 1. After I reach this value of 1. And at the end of this day, return what? Return. Oh shit. So that ends up, right? So let's have a quick recap. I don't know where to start here. But then divide two 32-bit integers is going to be that. So when you're going to divide 32-bit integers, you will have what? You'll have a dividend, divisor, quotient, and then you have a remainder. Okay? So you start off like this. It is always dividend, okay, into quotient plus remainder. So your aim is to find this quotient, okay? And you're trying to derive this quotient in the form of 2's. That is the basic idea behind the entire logic of the program, okay? So, as it's the power of 2's, what can you do basically? You can use the left shift operator, fine? So, since it's 32 bits, you start from the 31st bit, go forward up to 0, then I minus minus. So, for every bit I try to check, okay, based on the divisor. So, divisor into 2 power I. Is it divisible? Okay, is it lesser or equal to the dividend? So if yes, what I do? Okay, I already got that much. So I'm going to store that much value inside this 10. So 10 is initially 0, okay? I start from the last and then I'm trying to store, okay, accumulate my values, fine, got so far. And then separately I'm getting the quotient value. So how do I get the value of quotient? Separately using 1, okay? And then you do this. You return the quotient. At times, right, that can be a change in the signs between the signs of the dividend and divisor. So at that time, right, if you have to first extract the sign of the dividend or the divisor separately, and then go for the absolute value of both of these, and then perform the same logic. All right. So just write this question out, in your C++ portal and